When we use the method of direct comparison, what we should do is that we should compare these equations to something that we're familiar with, which is like a p-series or a geometric series. So in this case, if you look at the first one, you can see that n squared plus 2 is bigger than n squared. So 1 over n squared plus 2 is smaller than 1 over n squared. We know that 1 over n squared is convergent, which you should state as p equals to 2 greater than 1. So it is convergent. Now since this is convergent and this series is smaller than 1 over n squared, then this series converge by direct comparison. This is the phrase you should indicate in every end of your questions. So in the second one again, 3n squared plus 6 is greater than n squared. So we get the same logic and we get the answer to be converges by direct comparison. Now in the last one, this time n minus 3 is smaller than n. So 1 over n minus 3 is greater than 1 over n. Now we know that 1 over n diverges because p is equal to 1, which is equal to 1, which indicates that it diverges. So the series diverges by direct comparison. In this one, we can say that ln n is greater than 1. So this whole equation is greater than 1 over n plus 2. Now, if we're comparing this to 1 over n, this plus 2 becomes insignificant. So then we can say that it acts like 1 over n, which is divergent, because p is equal to 1 and this is a p series. So then we should say again, the series diverges by direct comparison. In the next one, after some point n factorial is greater than n cubed, always. So that means 1 over n factorial is smaller than 1 over n cubed. Now when we go to very big numbers, this minus 1 becomes insignificant. So then we can say n minus 1 over n factorial is smaller than n over n cubed, which if we simplify, n minus 1 over n factorial is smaller than 1 over n squared. And since this is a p series with p equals to 2 greater than 1, this converges. So the series converges by direct comparison. In the ratio test, you put n plus 1 instead of n to see how the next term is acting. So in this case, we put n plus 1 to top and then n plus 1, which makes the bottom n plus 2 factorial. So now we're going to divide this, which means that we're going to multiply this by the reciprocal of our function, which is n plus 1 factorial over 2 to n. So we will get a 2 here and then an n plus 1 factorial in the end. So then as limit of n approaches infinity, we will get this limit to be 0. So when the ratio test gives us the number 0, it means that the series converges by the ratio test. Our rule for this is that if the limit is smaller than 1, then it converges. If the limit is greater than 1, then it diverges. But if the limit is equal to 1, then it's inconclusive, and we look for another test to solve the problem. One other comparison method is called the limit comparison test. Now, for example, in the first one, we can compare this with 1 over n. And we can say limit as n approaches to infinity. Now, as n approaches to infinity, we get the limit of this to be 1. Which means that if the limit is 1, then that means this will act the same way as this does. This one does. So if 1 over n diverges, which it does since it's a p series and p is equal to 1, so then this will also diverge by limit comparison. It's the same logic. It's just that instead of saying that plus 2 is insignificant, you compare it to another function, and then you take the limit of n to be infinity, then you find a limit. If there is a limit, which in this case there is, then the top one will act like the bottom one, and if one diverges, then the other one also diverges. If one converges, then the other one also converges. This is how this test works. In the root test, our rule is that when we take the nth root of these functions, if we get something bigger than 1, then it diverges. If we get something smaller than 1, then it converges. Now, let's take this one. If we take the nth root of this function, we would get 3n over n plus 1. So, this function's limit as n approaches to infinity is 3. Since 3 is bigger than 1, then the series diverges by root test. If it was equal to 1, then again it would be inconclusive, just like it was in the ratio test.